In this video, I'm going to show how we can use a graph to determine where a function is increasing, decreasing, or constant. So if we look at this, this image here, we can see that we have a graph and it looks like an upside down parabola. And when you're trying to determine where a function is increasing or decreasing, one way to do that is to imagine that you're kind of walking along the curve. So if you're here and you're going on a hike and you're going this way, you're increasing, you're climbing up until you get to the peak. And then at that point, you're no longer increasing nor decreasing. And then we start to walk down, and then we're going down the hill, and we're decreasing there. So what we'd say is this function is increasing from A to B, and then this function is decreasing from B to C. And we write these locations in interval notation. And notice that we don't include the endpoints here. So we're not going to include B because at B, this function is neither increasing nor decreasing. It's like we're leveled off there. And then at A and C, this graph, there's a couple different ways we could interpret this. We have the arrows here, so it's kind of like this continues down. So we would say that this, if that was the case, instead of the A there, we could put from negative infinity to B. But because we're given the A value, I'm just going to say between A and B, this is increasing. Okay, and then let's look at an example where we're given the graph of a function. It says, given P of t, identify the intervals on which the function is increasing and decreasing. So I'm just going to lay this out here. Okay, so looking at this graph, well, again, imagine you're walking along this curve. And so it looks like to the left of 1 and up until 1, we're decreasing. And then from 1 to 3, we're climbing up. And then from 3 to 4, and then from 4 and to the right, it looks like we're increasing. So it looks like the places we are increasing are between 1 and 3, because the graph is, if you're walking along that curve, we're going up, and then from 4 to 5. So we'd say increasing 1 to 3, union 4 to infinity. And then the decreasing part of this graph is negative infinity to 1, and then 3 to 4. So negative infinity to 1, union 3 to 4. Now this might seem kind of obvious, but one common mistake that students will make is that they'll use the y values when they're describing where a function is increasing or decreasing. So anytime we're talking about where something is happening, we want to look at the x values. And if it said, what is the value when this is happening? That's the y values. So when we're asked that question, we want to think about the y values. And we'll see that in this next example. And that example is talking about the maximums and the minimums of a function. So we have two different types of maximums and minimums. We have local maximums and minimums, which is what we're going to talk about first. So the local max is the greatest value in a given interval, and the local min is the smallest value in a given interval. You can think of this as where the graph turns. So where it goes from increasing to decreasing, or vice versa, where the function goes from decreasing to increasing. So again, imagine you're going on a hike. When you go from descending or going downward to upward, that dip is a local minimum. And then where you go from increasing to decreasing, that crest is a local maximum. So if we look at this function, we can see that right here is where I'm going from the left of -1, I'm decreasing, and then I start to increase. So this point right here would be a local min. And this point, similarly, is where I'm going from increasing to decreasing. This value would be a local max. Okay, and what it's asking is, we need to talk about where this is increasing and decreasing also. So this function is increasing. Sometimes I can spell. Increasing. Okay, so looking at where this function is increasing, let me do a little erasing here. All right, so it looks like it's increasing between -1 and +1. That's where we would be going upward. So we're going to say -1 to +1. And then this function is decreasing from -infinity to -1. And then again from 1 to infinity. Okay, so if we were to kind of look at this on a sign chart, we see that from -1 to 1, that's where it's increasing. So I'm just going to put a plus there, and then it's decreasing over here. So if we want to determine where the maximum value and the minimum value is, well, we're decreasing here, and then we're increasing here, and then we're decreasing here. So at this point, in here, that's going to be where the local minimum is, and this is where the local maximum is. So again, where we go from decreasing to increasing, that's a minimum. Increasing to decreasing is a maximum. So we would say the local min is, we want to know what is the value at that minimum. And so what we see is at the dip is -2. It's when the value of the function is -2, and that occurs when x is -1. So the local min is -2 when x is equal to -1. Okay, and then the local max, that's saying what's the biggest y value. The local max is 2 when x is equal to 1. Okay, and the last thing to say about local mins and local maxes, this isn't this graph. We can see that it just keeps going up to infinity here, and it also keeps going down to -infinity. Now, there is no biggest value of this function because this graph just keeps going up and up and up towards positive infinity. So there's no absolute maximum value, and there's no absolute minimum value for this particular graph because it goes to the range is -infinity to positive infinity. But some functions do have an absolute max and min, and that's what we'll see here. So this is the greatest value of a function is the absolute max. The absolute min is the smallest value. For example, for the function f in this graph, find the absolute max and absolute min. Also, where do each of these occur? Okay, so the absolute max is the biggest value that this graph ever achieves. So if we're back to our hiking example, it's where's the peak of the mountain that we climbed? Or what is the elevation, I should say. What is the elevation of the mountain that we climbed? Well, in this graph, the elevation would be 16. And that occurs when x is equal to this value right here, -2, and when x is at 2. Okay, so that is the absolute max. The absolute max is 16, and it occurs at x equals -2 and +2. And then the absolute minimum value is down here, maybe -10. And that occurs in one place, and that's when x is equal to 3. Now, something interesting is happening down here. At 0, 0, that looks like that's a local min. So this right here is a local minimum value. It's a place where the graph goes from decreasing to increasing. But it's only local. It's like if we're going on a hike and we go down a valley, it's not the lowest part of the hike, but it is a low point within the hike.